Welcome to today's class. Olarewaju Bolariwa is my name. Teaching is my calling. What do we have for today? Quadratic equation. Here we shall be breaking down how we solve quadratic equation questions in 4 methods. Starting from the factorization method, completing the square method, the formula method, which we popularly known as the almighty formula, and the last one, which is the graphical method. But before we go into that, let's recall from these 3 examples given here before we go into the factorization method. Looking at this, m squared equals to 16. Sure, to get our m is going to be square root of 16. But this time around, let's move even a little bit advanced beyond that. I can say my m is going to be square root or plus or minus square root of 16. What does this imply? It implies that, of course, square root of 16 is 4. But I can equally say square root of 16 is minus 4. It's not out of place to say it is minus 4. Because minus 4 multiplied by minus 4 will give me 16. Because minus multiplied by minus is plus. And 4 multiplied by 4 will give me 16 at the same time. So, we can now say our m is equal to plus or minus 4. And to break this down, we can also say it is 4 or minus 4. That is about that. Now for the second one here. In order to remove the square here, we are going to square root both sides. And by the time we square root both sides, the square root will cancel the square here. We will be left with x plus 2 equal to plus or minus square root of 25. So from here, we'll be having x plus 2 equal to plus or minus the square root of 25 is 5. So we have 5 here. But the intention is to find what our x will give us. So making x subject of the formula, we'll be having x equal to, the 2 will travel to this place, and each time a number travels over the equal sign, it changes the value, or it changes the sign. The sign is changed. So we have a plus 2 here. So coming down here will become minus 2. So we have minus 2 plus or minus 5. So from here, we break it. So we break it into 2. So to break it, we'll be having x equal to minus 2. Let's make use of the plus first. Plus 5, or x is equal to the minus 2. So we are not using the plus this time around. We are using the second option, which is the minus. So minus 5. So finishing this, minus 2 plus 5. You are owing 2 and you have 5. So by the time you pay the 2 you are owing from the 5 you have, you will be left with 3. So this gives us 3, or x is going to be minus 2 and minus 5. You are owing 2 and you are equally owing 5. So altogether you will be owing 7. So this gives us minus 7. Easy. Going to the third one now. This is a mixed fraction and a mixed fraction. So let's try to change this one from a mixed fraction to an improper fraction. So we have x, of course in bracket, 2 multiplied by 2, 4. 4 plus 1, we have 5 over 2. Square equal to 4 multiplied by 6, 24. 24 plus 1, we have 25 all over 4. So removing the square here will result to square root at the other side. X minus 5 over 2 equal to, don't forget the plus or minus sign. It's very important while solving questions from quadratic equation. So we'll now have square root of 25 all over 4. Now from here, the square root of 25 is 5. The square root of 4 is 2. So this results to x minus 5 over 2 equal to plus or minus the square root of 25, like I said earlier, 5, and the square root of 4 will give us 2. We want to find what x will give us. So for this, our x staying here minus 5 over 2 traveling to the other side will result to addition. So we have 5 over 2. I'm referring to this minus 5 over 2 coming down here. The sign will change to plus. So I don't need to write plus here. So it's already a positive value. 5 over 2. Then what do we have here? Plus or minus 5 over 2 again. Now let's break. X is equal to 5 over 2. I'm using the plus first, plus 5 over 2. Or x is equal to 5 over 2 minus 5 over 2. Then this. They are fraction. So we have LCM, of course, to be 2. As a matter of fact, the bases or the denominators are the same. So we have 2. So 2 divided by 2, we have 1. 1 multiplied by 5, we have 5. Also again here, 2 divided by 2, we have 1. 1 multiplied by 5, we also have 5. Or, for this, you can simply have it to be results to, you can easily have this to be 0. How is this going to be 0? 5 over 2 minus 5 over 2. You have 5 over 2, you have to do 5 over 2. Of course, it will end up to be 0. 10 minus 10 is 0. 50 minus 50 is 0. So 5 over 2 minus 5 over 2 will result to 0. So we have 0 here. So 5 plus 5, this will give us 10 all over 2 or an x, which is already 0. So 10 over 2 will give us 5 or x is equal to 0. Easy. Alright, having done that, let's try to move into the factorization method. So before we go to the equation, let's start with expression. Expressions are the questions or values given to us without an equal to sign. But the moment you have an equal to 0 or equal to any figure, it becomes a quadratic equation. It becomes an equation. So we have this expression. Let's start the work from factorizing these expressions. So the first one here, let me have my solution here. The first one. But before we go to that, before we even start that, let's recall the difference of two squares. The difference, recall the difference of two squares. That means each time we have two squares, we apply this method. So for instance, we have x squared minus y squared. This is a square, this is a square. When we say difference, it indicates minus, subtraction sign. So the difference of two squares will always result in this. X plus y, open bracket and close bracket, multiplied by x minus y. This is equivalent to this. And for the benefit of doubt, we can try to open this bracket. It will give us x multiplied by x, we have x squared. X multiplied by minus y, we have minus xy. Y multiplied by x, we have plus xy. And finally, y multiplied by minus y will give us minus y squared. So when you try to collect the like terms from here, x squared, already started, staying here, minus xy plus xy. You are only xy and you have xy. The two will cancel each other. That's done. Then you have the final one, which is y squared. That means x squared minus y squared is equal to x plus y in brackets. Open another bracket, x minus y, close bracket. Now back to the question. T squared minus 36. 36 is a perfect square. So we just get our 36 to become 6 raised to power 2. This gives us t squared minus 6 squared. Now this is 2 squares. T is having square, 6 is having square, and the operation between them is subtraction, difference of 2 squares. Then we apply it by saying t plus 6, at the same time t minus 6. Anyone can come first. You can choose to start with t minus 6 and t plus 6. And for benefit of doubt, you want to expand this to proof. Like you want to check this, t multiplied by t, you have t squared. T multiplied by minus 6, you have minus 6t. And 6 multiplied by t, you have plus 6t. Finally, 6 multiplied by minus 6, you have minus 36. Minus 6t plus 60, you have 60, and you are weighing 60. All the t's are gone. So you have t squared minus 36. T squared minus 36. So that means t squared minus 6 squared is still the same thing as t squared minus 36. Easy. Now for the second one, 2r squared minus 32. 32 is not a perfect square. So we try to maneuver this by first dividing the 2 by 2. You divide this left side and the right side by 2. So when you do that, you will be left with r squared minus, by the time you divide 32 by 2, you will be left with 16. And from here, you now have r squared minus 4 squared. 4 squared is 16. Then you now find the difference of 2 squares, which will give us, I'll deliberately start with the minus. R minus 4 and R plus 4. Factorized. Easy. For the third one, x raised to power 2, we now have 1 all over 4. The 1 all over 4 is also a perfect square. How do we go with that? The 4, by the time you turn it to 2 raised to power 2, it becomes 4. Likewise, the 1 raised to power 2 is still going to be 1. This is telling us that we cannot see 1 all over 2, perhaps in brackets, raised to power 2. It's still the same thing as 1 all over 4, because 1 multiplied by 1 will be 1. 2 raised to power 2, which means 2 multiplied by 2, is going to give us 4. So 1 all over 2 raised to the power of 2 is still the same thing as 1 all over 4. Now, by applying the process of difference of 2 squared, this gives us x plus 1 all over 2 in bracket. Once again, x minus 1 all over 2 in bracket 2. By the time you do this, you have factorized the question here. Easy. So the next that we shall be taking will be the quadratic equation using the factorization method. Without wasting time, we have these 4 examples here, which we are going to solve by using the factorization method. In the later session of the video presentation, we shall be using the completing the square method, and we shall also be using the formula method. So right now we are working on the factorization method to solve this question. Now the first one, x squared plus 11x plus 18 all to give us 0. What we are going to do here is to multiply this and this together. Now let me write it again. We have an equation here because of the equal to 0. So we are going to multiply this and this together. How do we identify this? The one that has square is the A. We regard it as the A. And the one that is not having any form of alphabet, we regard it as the C, which is the constant. So the first step is to multiply the A and C together. Then what is the one in the middle? That one is called the B. The B in the sense that it has only the alphabet without power. Now multiplying the A and the C together, it will give us 18x squared. Upon having 18x squared, we are now going to look for two factors. I'm going to do it like this. Two values in such a way that when you multiply the two together, the two values, it must give us what we have here, which is 18x squared. The same value, by the time you add them together, it must give you what you have in the middle, which is 11x. We now start thinking of the factors that we can multiply together to give us 18. Of course, I can start with 18 and 1. 18 multiplied by 1 will give us 18. Nevertheless, how will 18 and 1 be added together to give us 11? It's not going to work. I will need to think of another factor. Of course, if I choose to say 9 multiplied by 2, 9 multiplied by 2 will give me 18. And 9 plus 2 will give me 11. Then that is our factor. So I will say 9x, because we are dealing with, we are working around the x, and 2x. 9x and 2x. If you look at this vividly, 9 multiplied by 2, 18, x multiplied by x, we have x squared. At the same time, 9x plus 2x will give us 11x. That's our factor. Now, what do we do with the two factors? We are going to place it in between here. Instead of writing the 11, we are going to use the 9x plus 2x. X squared plus 9x plus 2x. Then our 18 here plus 18 equal to 0. So as we have it here, we have not done anything strange. Rather, we are even repeating what we have here, because this is 11x. Now, if we say 9x plus 2x, it's still the same thing as 11x. Now, what do we do next? We factorize this and this. What is common between this and this? We have x here, x equally goes here. So we have an x outside, open bracket, x squared divided by x. X squared divided by x means we have 2x divided by what? An x. Then takwa. We are left with what? An x. We put the x here. For this one, 9x divided by the x outside, 9x divided by the x, takwa. You are left with what? Just the 9. Close bracket. As for these two, what is common between the two? 2 goes here, fine. 2 goes here, 2, 9. But x is here, x is not here. It's not common between the two. So we are going to make use of just the 2. So we have plus 2 outside as a common factor. Now 2x divided by 2, 2 will cancel 2, you have an x. Once again, 18 divided by 2, 18 divided by 2 will give us 9. So we have plus 9, all to give us 0. Now, having this, we have the two values in the brackets to be the same as expected. So, by using the cramming method, all you just need to do is to pick one of the two values that are in the bracket that are the same and group the ones that are outside of the bracket, put them in the same bracket. That is when you choose to just cram it. But if you want to understand what is happening here, you need to factorize all over again by saying what is common from here to here and from here to here. We have x plus 9 to be here, and x plus 9 is also here. Then you bring it out. X plus 9 is here. So when we have that, by the time you divide everything here by x plus 9, you are going to be left with x. I guess you get what I'm saying. By the time you divide everything here, you are going to be left with x. So we have an x here. Once again, when you have everything here, by the time you divide everything here by x plus 9, you are going to be left with 2. Then we have plus 2 here. All to give us 0. Our intention is to get what x is. So x plus 9 is equal to 0, or x plus 2 is equal to 0. X is going to be, the 9 will come here, it will become minus 9, or we have the x to be equal to, by the time the 2 comes here, it becomes minus 2. Easy. So our x is either minus 9 or minus 2. If you substitute these values into this equation, you will see that it will end up to be equal to 0. So we have the second one, 6a squared plus 13a minus 5, all to give us 0. The first step, when you are using the factorization method, we multiply the a and the c together. So by the time you multiply 6a squared and minus 5, it will give us minus 30a squared. Upon having minus 30a squared, we are going to look for the two factors. I will use here and this. When you multiply the two factors, it must give us minus 30a squared. And when you sum them together, when they are added together, it must give us the one in the middle, which is 13a. So we think, what are the two factors that we could use that will give us this? If we choose 10 and 3, fine. 10 multiplied by 3 will give us 30. Considering the fact that we have a minus here, we have to work around it so that it will give us minus 30a squared. So if I say 10a, 3a to start with, I now need to think of where to put the negative sign. If I put it here in front of minus 10, minus 10 multiplied by 3 will give me minus 30. Fine. But what will now happen to the 13a in the middle? It will not work in that way, because minus 10 plus 3a will not give me 13a. Then I need to think again. If I choose to remove the minus from here, place it in front of the minus 3, it will give me minus 30a to start with. But what happens to my 13a? It will still work, because 10a plus minus 3a, it will give me 7a. If I choose again by applying minus here and minus here, it will not work again, because minus 10a multiplied by minus 3a will give me plus 30a. Then I need to think of some other factors. So as this is still not working, I need to think out of the box. That indicates that 10 and 3 cannot work. Though it looks as if it could work, it's not going to work. Then I should consider using 15 and 2. So what do we have for 15 and 2? I'm going to clear this one off because it's not in any way working. So 15 and 2, 15a multiplied by 2a will not give me minus 30. But if I put the minus in front of 2a, it will give me minus 30a squared. Furthermore, let's see if 15a and minus 2a will give me 13a. Bingo! It works. 15a plus minus 2a, I have 15a, and I'm asked to remove 2a from it. It's going to give me 13a. So we have our factors here. So proceed by saying 6a, then plus 15a, and what? Minus 2a minus 5, all to give us 0. 15a minus 2a will still give us 13a. So we have to be very careful while identifying our factors. What is common here and common here? 3 goes here, 3 also goes here. We have A here, we also have A here. So we are having 3A to be the common factors. So 6 divided by 3, we have 2. A squared divided by A, the A we cast one of the 2A, so we are left with 2A. Going to this place, 15A divided by 3A. 3 goes here, 1, 3 goes here, 5. A will cancel A. Now, looking at this, we have minus 2A minus 5. What is common between the two? 2 cannot go here and also go here. This one has A, this one does not have A. Since no factor can visibly go here, definitely 1 will go in such factors. Now, we are going to say we have a minus here and also minus is present here. So we are going to have minus 1 as the factor that is common between the two. So open the bracket. Minus 2A divided by minus 1. Minus cancels minus. Then 2A divided by 1, we have 2A again. Minus 5 divided by minus 1. Minus we cancel minus. Then 5 divided by 1, we have 5 plus 5. All to give us 0. Like I said earlier, you can choose to use the cramming method by assuming that since we have the two values here, you write it together, and the ones that are outside, you group them together. Or you work it like what is common between here and here. We have 2A plus 5, 2A plus 5. We have it grouped out, 2A plus 5. And when you divide everything here by this, you are left with what? 3A. And here too, when you divide everything here by this, the 2A plus 5 will cancel 2A plus 5, you will be left with minus 1. All to give us 0. So we group them by saying 2A plus 5 is equal to 0, or 3A minus 1 equal to 0. We are looking for A. We are making A subject of the formula. So we have 2A to be equal to 5 goes here. It becomes minus 5. Or 3A, which is here already, minus 1 travels here. It becomes positive 1. So making A subject of the formula, so A is going to be equal to minus 5 over 2, or A equal to 1 all over 3. Easy. So the third one, here we are going to first open the bracket as if we are working on algebraic process. So x multiplied by x, then x multiplied by 1. So x multiplied by x will give us x squared, and after that x multiplied by 1 will give us x. We are clear with this. Now going to the other side, which is 2 minus 5x squared. Now, having done that, we are going to collect the like terms. We have our x squared here already, and this is minus 5x squared. So we move it to this side. We have our 2 here already, we move it to this side also. So we shall be having x squared already given here, minus 5x squared coming down to this side will become a plus 5x squared. We have plus 5x squared. We have our x already here, so which is still present. Then finally the 2 we move to this side, it will become minus 2, all to give us nothing at the right side. Our quadratic equation is beginning to have shape. When we are collecting the right terms again, x squared is here, x squared is here. They can work together. We have 1x squared. At the same time, we have to add 5x squared to it. So if I have 1x squared and I'm to add another 5x squared to it, so I'll be left with 6x squared. So this is going to result to 6x squared. Then we have the x here at the middle, which is our b, and finally the c, which is minus 2 equal to 0. Now our quadratic equation is set. The next thing is to multiply the a and the c together. This will give me minus 12x squared without wasting time. Now we need to think, what are the two factors that will give us minus 12x squared when we multiply the two together? To give us minus 12x squared. Furthermore, when you sum the two together, it must give us the middle, which is x. So we start thinking, what are the two factors? When we start with 6 and 2, 6 multiplied by 2 will give us 12. But there is no way you add 6 and 2 together to give us 1. So we think of another factor. 12 and 1 will give us 12, fine. But 12 plus 1 will never give us 1. Then we think of another factor again. What will we use to give us 12? Of course, it's going to be 4 and 3. By the time you consider 4x and 3x, when you multiply the two together, it will give us 12. But logically again, when you think of 4 and 3, it will surely give us the 1. So that means if you put the minus in front of 4, it will give you minus x, of which our value as b is just an x, which the coefficient is 1, not minus 1. So of course, we are going to place the minus here so that we can have the expected outcome. So 4 multiplied by minus 3 will give us minus 12, and the x multiplied by x will give us x squared. So we have it here again, 4x and minus 3x. So surely by the time we work on this, it will give us an x. So let's apply this into this our equation. 6x squared plus 4x minus 3x, then minus 2, all will give us 0. So we factorize. What is common here and common here? We have 2 to be common. Furthermore, we have x and x here. So it's going to be 2x, all open brackets. 6 divided by 2, we have 3. X squared divided by x, we have an x. Then x. As for this, 4x divided by 2x. 4 divided by 2, this will give us 2. X will cancel x. Clear. On to this side, what is common here and common here? This is so similar to what we did earlier. So, absolutely 2 cannot go, 3 cannot go into. But of course, if no factor can go, 1 will surely go. But considering the sign we have here as minus and minus, so it's going to be a minus 1. So we have minus 1, open bracket, minus will cancel minus. 3x divided by 1, we have 3x. At the same time, minus 2 divided by minus 1, minus will cancel minus. 2 divided by 1, we have a positive 2. All to give us 0. Let me clear this to avoid any form of error. We are through with this. Looking at this, we have our value in the bracket to be the same. So without wasting time, I'll pick on this, I group it as 1. I pick on this, I group it as 1. So anyone can come first. I can say my 3x plus 2 is equal to 0, or the one that are outside, which is 2x minus 1 equal to 0. Making my x subject to the formula x is 3x, is equal to the 2 coming down to this side will become minus 2, or 2x minus 1 coming to this side will become positive 1. So what is our x here? X is going to be minus 2 all over the 3, which is the coefficient here. We have 3. Or x as subject of the formula is going to be equal to 1 all over 2. Easy. So the number 4. The number 4 also requires cleaning what we have here to make it our convenient quadratic equation. So we have them as fractions. So what we will do here is simple and easy. As a matter of fact, we have this, and this. we group them together. Let's start from there. We have x squared. By the time you collect your like terms, we have this one already present, minus 3x all over 4. This comes here too. We have minus 1 over 3 already. By the time it comes here, it becomes plus 1 over 3. We have plus 1 all over 3x. Then finally 1 all over 6. It goes to the other side. The sign will change from being positive to being negative. So we have minus 1 all over 6, all to result to 0. Now we embark on the journey properly. They are all fractions. To stop them from being a fraction, let's assume that this is also all over 1. To stop this from being a fraction, because it's going to affect how we proceed with the question. So we are going to find the LCM of the denominator, and the LCM of the denominator, we are going to use it to multiply the numerator. By doing that, we are going to clear the fractions. Now the LCM of 4, 3, and 6 is going to be 12. It's going to be 12. So we are multiplying every numerator by 12. So by the time we multiply everything here by 12, so it's like having 12 multiplied by x squared. We have 12x squared over 1. Okay? By the time we multiply 12 and minus 3, it's going to give us 36. So we have 36x all over 4. And for this place, 12 multiplied by 1, we are going to have 12 over 3x. And finally for this, 12 multiplied by 1 again is going to give us minus 12 all over 6, all to give us 0. 12 divided by 1, we have 12x squared. So 4 in 36 is going to give us 9. We have minus 9x. Then 3 in 12, we have 4x. Once again, 3 or 6 in 12 is going to give us minus 2 equal to 0. Now we are having it to be clearer gradually. Collection of like terms. This is x squared. We cannot work it along with anything. But we have minus 9x plus 4x. I'm only 9. I have 4. So I'll be left with minus 5 of the x. 12x squared minus 5x minus 2 equal to 7. So by the time I multiply this and this together, it will give me minus 24x squared. So looking at the factors here, what are we going to multiply together to give us 24x squared? And by the time we sum them, it's going to give us minus 5 that we have in between. So we can start to think like, okay, 6 and 4 will give us 24. But by the time you multiply or you sum 6 and 4 together, it will never give us minus 5. Then what else can we think of? 12 and 2. 12 and 2 will give us 24. But there is no way that we manipulate 12 and 2 to give us 5. So we think of another factor that we could use. What about if we use 8 multiplied by 3? 8 multiplied by 3 will give us 24. And when you sum 8 and 3 together, it will give us 5. So it's looking like 8 and 3 will give us what we are looking for. So now where do we put the signs? Where do we put the minus? Because of this. So 8 and 5. 8 and 3. Where do we put it? We have 12x squared. Now let's have our 8x and 3x. Then finally minus 2, all to give us 0. Now, where do we put the sign? We now need to think of the appropriate place to put the sign. So, looking at this, for us to have a minus 5, definitely the sign will be in front of 8. Then we have a plus 3. Now, let's check if this will work. By the time you multiply minus 8x and 3x together, it will give us minus 24x². And when you sum them together, it's going to give us minus 5x. So from here, let's factorize. What is common here and common here? 4 goes here, 4 goes here. You cannot use 2. It's not the highest common factor. Of course, 2x goes into 2, but we still have an higher value. So which is going to be 4x. So we have 4x, open bracket, 4 into 12 will give us 3. X² divided by x, we have an x. 4 in 8, we have 2. X will cancel x. As for this, nothing goes apart from 1. So we have plus 1. Then 3x minus 2, all to give us 0. So when we choose to pick the ones outside to be equal to 0, and the one in the bracket, we pick one of it to be equal to 0. 4x plus 1 equal to 0, or 3x minus 2 equal to 0. 4x is going to be equal to 1, coming to this place becomes minus 1, or 3x equal to minus 2 will come here, it will become a positive 2. Now finally, we have x to be equal to minus 1 all over 4, or x to be equal to 2 all over 3. Easy. So the next one, which is quadratic equation from given root. We may be asked to generate the quadratic equation from the given root. So for the purpose of this class, I've decided to use the root that we got from this quadratic equation in order to get what the equation is. So let's assume that we are given the root of a quadratic equation and we are asked to get the quadratic equation. The method of solving it is as simple as this. To solve it is going to be, open bracket, x minus the first given root, and we shall multiply it again by saying x minus the second given root. What do I mean by this? The first given root here, we place it here. The second given root, we place it here. By the time you multiply the two together, it's going to get the quadratic equation that led to the root. Now let's start with the first one. Open bracket, x multiplied by the first root. X multiplied by the first root. What is the first root? Minus 9. So we have a minus 9 as the first root. Opening the bracket again for the second one. X minus the second root. What is the second root? Minus 2. So we have minus 2 here. Close the bracket. So minus multiplied by minus, we have plus. So x plus 9, close bracket. X again, minus times minus, we have plus. Plus 2, close bracket. So we can now open this bracket. So by the time we open this bracket, we are going to have x multiplied by x, x squared, x multiplied by 2, we have 2x, and 9 multiplied by x, it will give us 9x. Finally, 9 multiplied by 2, this will give us 18 as the constant. So all to give us 0. We move further by saying x squared 2 plus 9, it will give us 11x, then plus 18 equal to 0. Let's check this and check this. Easy. So the second one, we have our roots to bring in fraction. So we solve it all over again by adding Of course, they use a as the variable. It does not matter either you are using a or x. So far it is a variable. So we have x minus the first root, which is minus 5 all over 2. First one. We open bracket again. X minus the second root. Here is a positive value, which is 1 all over 3. Close brackets. By the time we treat this accordingly, minus times minus, we have plus. So we have x, then plus 5 all over 2. We have this as well, x minus 1 all over 3. Now we open the brackets. X multiplied by x, we have x squared. X multiplied by minus 1 all over 3. 1 multiplied by x, x. So we have minus x all over 3. Furthermore, 5 multiplied by x, it gives us 5x all over 2. Finally, 5 all over 2 multiplied by 1 all over 3. Plus times minus to start with, we have minus. 5 multiplied by 1, it gives us 5. Then 2 multiplied by 3, it gives us 6. All to give us 0. Now from here, we work on this. Like everything here is in fraction. So we can find the LCM of everything and multiply it by the numerator in order to stop it from being a fraction. The LCM of what we have here is going to be 6. So upon having it as 6, we are going to multiply all the numerator by the 6. So 6 multiplied by x squared, we have 6x squared. 6 multiplied by x is going to be minus 6x, of course, all over 3. Furthermore, 6 multiplied by 5, it gives us 30. We have 30x all over 2. Then 6 multiplied by 5 here again, we have minus 30 all over the 6. All to give us 0. Then the next thing is going to be to break it. 6x squared. 3 in 6, we have 2. So that's going to be minus 2x. 2 in 30, it will give us 15x. Then 6 in 30 here will give us minus 5. All to give us 0. Now we collect the right hand. 6x squared here. Then minus 2 plus 15. They are both x. They can work together. So if you are only 2, you have 15. You are going to be left with 13. So we have plus 13x. Finally, our minus 5 will give us 0. Let's verify if they are the same. 6a squared plus 13a minus 5. 6x squared plus 13x minus 5. Easy. Thank you so much for your time. I'll be leaving you at the beginner's level at this point. So you have this task to tackle. The first one here and the second one here, you get the root of this quadratic equation. And for the question number 3 and 4 that are left here, I'm leaving this to you, my viewers, to generate the quadratic equation that led to these two roots. And please do give me your answers at the comment section. And don't forget to like this, subscribe to this channel, and share with your loved ones. So till when else I see you again, I say peace.